Welcome to an introduction to Beam Flux Monitor calibrations in Nexus. In this video, we will explore the Beam Flux Monitor tool in Nexus. This function is a step to calibrating your system. The Beam Flux Monitor allows you to record beam equivalent pressure values. You can do this for every source. The first goal of this process is to map out the relationship between a given source temperature and its beam equivalent pressure. To do this, we gather a series of beam equivalent pressure data points in millibars. This chart shows a data series for indium. Let's briefly dive into how we gather each data point. First, we heat the indium cell to a specific temperature and leave it to stabilize. Then, we sum and average 5 different measurements of the background chamber pressure on the Beam Flux Monitor. Next, we open the indium shutter and leave the induced pressure to stabilize. After that, we sum and average 5 different measurements of the pressure on the Beam Flux Monitor. Finally, we close the shutter and calculate the correct beam equivalent pressure from the difference of these two values. As you can see, accurately reproducing this process for each data point, when done manually, takes a great deal of time. Nexus offers you several options. First, you can do the whole process we just described manually, and then enter the values you recorded and add a point using this button. Alternatively, after ramping the cell manually to the desired temperature, you can then click on Start Measurement to semi-automatically run the process in a single step. This will record and calculate the beam equivalent pressure for you and then add it to the chart. Alternatively, you can create either classic or Python recipes to gather one, several, or a full set of data points for every source and fully automatically calibrate all beam equivalent pressures. The recipe looks like this. When the recorded BEP command is executed, the process runs automatically and the data is added to the Flux tool chart. Now, single point shifts the data. The addition of a single new data point is treated in a specific way. Nexus will shift the last 4 series up or down in the Y section to fit the new data point. This way, the previous 4 series becomes the foundation of a new value series. To display this change visually, the past and calculated data points show up in dark gray and light gray, respectively. This enables single-point calibrations that save time and money. Multiple points create a new series. If you add more than 3 data points, then Nexus will proceed to create a new full BEP series. The gray points will disappear. Trend lines. The lines here displayed are lines of best fit through the available data points. These are calculated for you automatically. You can change the polynomial order of the fit in here. Finally, converting from BEP to flux. The beam equivalent pressure can now be converted into atomic flux in atoms per nanometer squared per second. The conversion typically uses an additional tool, for example, read oscillations. This allows you to specify the conversion factor from BEP to flux. This flux that is supplied by the source is the flux that is incident on the sample. That is why we simply call it incident flux. This incident flux is fundamental to all parts of Nexus that predict thickness and composition of thin film layers. You can learn more about Nexus prediction features in our simulation tool video. And that is all for today. Thanks for watching. See you in the next video.